So hello students, this video I'm making for one of the topics which was requested the most, that is electricity numericals, and most of you have a problem in this part, and this is very important because at least 50% of your physics paper consists of application level questions, out of which numericals are the major part. So in this video I'll be explaining first the 5 steps to solve or crack any numerical, especially of electricity chapter. Part 2, I will be solving with you certain examples and I will illustrate the use of these 5 steps through those examples. And part 3 of the video will have some example problems which you can solve independently using these 5 steps. Step 1, so let's get into read the question carefully 2 times, minimum 2 times. Okay. So first reading, you can do a casual reading to understand from which chapter the question is, and in that chapter which concept is being used here, and to get an idea of which formula may be applied. Okay. Second reading, you have to focus on what data is given, what is given and what is asked in the question. What are you supposed to calculate and find out the answer? So these 2 readings are a must. If you are not able to find this data in the second reading as well, then please go for a third reading. Okay. Then step 2. So step 2 is writing down the given data and what is asked. So when you're writing down, make sure you use the symbol to write. For example, in a question, current is given, potential difference is given, and you are asked to calculate the resistance of the conductor. So you should write as V is equal to so and so, I is equal to so and R is equal to question mark, because R is the unknown there. So what is the use of doing this step? When you see it on the paper in symbols, you can quickly recall the formula. So here when you see the letters V, I and R, quickly the formula V is equal to IR comes into your mind. So if you have learnt the formula in symbols, this step will help you a lot to identify the formula that is needed. Step 3. So by now you have identified the formula that is to be used. Till here, if you do, you will get half marks in the question just by writing the formula. So please don't skip this step. Next step is substitution. So while substituting, you have to be very careful to see the sign of that particular quantity. So in chapter electricity, you don't have to be very careful about the sign. As it is given, you have to substitute, you have to place the values in the formula. Step 4 is calculation. So this is the part where many of you go wrong, where you know how to solve but still you get the wrong answer, and most of the time it is because of careless mistakes. Maybe instead of adding you multiply, or instead of dividing you add. So these kind of, or maybe you don't keep be careful about the sign. So be very careful while doing these. The calculations will be very simple, and the key to crack this step is practice. Practice as many questions as you can so that your calculation mistakes will be minimum. Okay. Coming to step 5. Step 5 is verification or checking. So again, go back, check each of the steps that you have done till now, especially step 4 calculation. You need to check and see if your final answer is correct or not. When you're writing the final answer, you should be very careful about the unit in which you're writing the answer. Go through these 5 steps to crack any of the problems with lots and lots of practice. Just knowing the steps will not help. So let's go to part 2 of the video where we'll be solving certain problems. So we'll be solving 5 problems here. Let's go to the first problem. Step 1, reading. A radio set draws a current of 0.36 ampere for 15 minutes. Calculate the amount of electric charge that flows through the circuit. So in our second reading, we underline or we see what is given. So current of 0.36 ampere and time is 15 minutes, and electric charge is asked here. So step 2, let's write down what is given. So current is I, is equal to 0.36 amperes. Time is given as 15 minutes. Now here time is given in minutes. We need to convert into SI units, that is seconds. Just 900 seconds. 15 into 60, 900 seconds. Since 1 minute is 60 seconds. And Q, that is electric charge, is asked. So immediately we can recall the formula I is equal to Q by T, since this formula involves all these three letters, or Q is equal to IT, just by transposing. Now step 3 is substitution. Let's substitute 0.36 for I and 900 for T. Step 4, calculation. So 0.36 multiplied by 900 gives you 324 coulombs. Step 5 is verification. You should check each of the values. If you have noted down the values from the question correctly, have you converted the units, have you written the correct unit, and check the calculation. Now let's go to question number 2. How does the resistance of a wire change when A, length is tripled, B, diameter is tripled, and C, material is changed to the one whose resistivity is 3 times? Now, first reading tells you that the question is from the topic factors affecting resistance. So, how resistance is given, length is given, diameter is given instead of area of cross section, and resistivity rho is given. So, we can write those down. So immediately the formula connected to this concept is R is equal to rho L by A, where A is not given, but we know that A is equal to pi r square, radius square, and radius is half of diameter, so pi d by 2 square, which is pi d square by 4. So these things are known to us, so we can recall the formula like this just by writing down the symbols. Now, we know that resistance is directly proportional to length. So, if length becomes 3 times, what happens to the resistance? Resistance also becomes 3 times, since resistance is directly proportional to length. So, this is an application based question. So, since length is tripled, the resistance also becomes 3 times. So, 3 or resistance is increased by 3 times. This is the answer for part A. Now part B, we know that resistance is inversely proportional to area of cross section, but area of cross section is not given. Diameter is given to be tripled, made 3 times. So from this formula, area is pi d square by 4. You can say that if diameter is tripled, means diameter becomes 3d. So d square means 3d square, 9d square. So area also becomes 9 times, or area increases by 9 times if diameter increases by 3 times. Okay. So if area increases by 9 times, resistance decreases by 9 times, because resistance is inversely proportional to area. So resistance decreases by 9 times. Let's go to part 3, C. Here resistivity is made 3 times. So very simple. From the formula R is equal to rho L by A, we know that resistance is directly proportional to rho. So if rho increases by 3 times, resistance also increases by 3 times. So this was a pretty simple question. Next is a circuit diagram which involves series parallel connections. So the formula, now read the question. 3 resistors are connected as shown. We have to find through the resistor 55 ohm a current of 1 ampere flows. So what is the current through the other 2 resistors? B, what is the potential difference across AB and AC, and what is the total resistance? So through the 5 ohm resistor, current is given as 1 ampere. Let me just name all the resistors R1, R2, R3, and here I'll show where is the battery connected. This is not needed, just for your understanding how current flows. So I added a battery to it. So in the question it's given that from A to C you have to find A to B you have to find potential difference, and also from A to C. So that's part B, and you have to find out the total resistance as well. So let's come to part A. What is the current through the other 2 resistances, that is R2 and R3? So current goes through R1, then gets split to R2 and R3. Okay, let it be I2 and I3. Okay, let the current be I2 and I3, or I1 and I2. So what is I1 and I2? It is not given here. Okay. So these are the two things that you have to find. But before that, you can notice R2 and R3 are parallel to each other. So let's find out their equivalent resistance. So 1 by Rp equal to 1 by R1 plus 1 by R2. This is the formula for equivalent resistance. Or 1 by 10. R2 is 10, R3 is 15. 1 by 10 plus 1 by 15. So this is step 3 calculation. You can calculate. Take the LCM 30. 2 plus 3 plus 2, so 5 by 30. So 1 by Rp comes out to be 5 by 30, which is 1 by 6. Or Rp is the reciprocal, 30 by 5, which is 6 ohms. So your equivalent resistance, the R2 and R3, they act as 5 6 ohm resistor. Both of them together act as a 6 ohm resistor. So what is the resistance current has to face here? 6 ohm in total. So what is the potential difference across B and C? V equal to IR, Ohm's law. Current is 1 given, and R we just found out to be 6. So the potential difference from B to C is 6 volts. So if V is 6 volts from B to C, that is across the parallel connection, then what will be the current through the second resistor R2? That is I1 is equal to V by R2, 6 by 10.6 amperes. Sorry, let's take it as I2 only, since the resistor is R2. So I2 equal to V by R2, 6 by 10, which is 0.6 amperes. Here instead of I1, I made it as I2, please note, so that we don't get confused. And the other current, let's take it as I3, which is V by I3. V is 6 divided by I3 is 15. So 6 by 15 is 0.4 amperes. So here you can notice I2 plus I3, 0.6 plus 0.4 gives you again 1 ampere. So it shows that the current was split into the two resistors. Now second is you have to find out the potential difference across AB. So the AB. So across AB there is only one resistor, which is 5 ohm resistor R1. 5 ohm resistor. So V is equal to IR. I is 1 ampere through R1. So 1 into R1 is 5. So 1 into 5, 5 volts. So potential difference across AB is 5 volts. Now V across AC we need to find. So across AC we have these 3 resistors. And out of the 3 resistors, there is one parallel combination which acts as a 6 ohm resistor, and there is one 5 ohm. So 5 ohm and 6 ohm are in series. So let us first find out the equivalent resistance in between A and C, the points A and C, which is R1 plus R2. The RP, the parallel combination, which is 5 plus 6 is the parallel combination, which is 11 ohms. So once you get the equivalent resistance, you can just substitute V is equal to IR. Current is 1 and R is 11. So 11 volts. Now let's go to third part of the question, which we have already solved. So third part asks you for the equivalent resistance in the circuit. So this we have already solved. You can go back and see the video once again, which is 11 ohms. So 5 in series and the other 2 in parallel. So let's come to question number 4. This is again a series parallel combination question. The circuit looks complicated at the first look, but then it becomes easy. So here each resistance is given as 3 ohms. 5 resistors are there. First thing you need to identify which are in series, which are in parallel, and a battery of 4 volts is connected. You need to find out ammeter reading, means you need to calculate the current. So here first thing is look at the battery. So from positive terminal current starts flowing, goes to R5, then it gets split into R4 and R3. Right? So these are 2 parallel branches. So this is in parallel. Now from R3 the same current goes to R2. So it shows you that R2 and R3 are in series because same current is flowing. So here R4 is parallel to the series combination of R2 and R3. And then these two currents combine and go to R1. So it shows R5 in this whole network and R1. These three things are in series. So first we solve this network, then R5 plus the network plus R1. So now let's simplify this network. How to solve? First do R2 plus R3 because they are in series. Then that is in parallel with R4. So let's start. First is you find out series R2 plus R3, which is 3 plus 3, 6 ohms. Okay. Now this 6 ohm is in parallel to R4. So let's find out the parallel combination 1 by R4 plus the one that we found out now RS, that is series. 1 by 3 plus 1 by 6. The series combination is equal to 6. 3 plus 3. When you solve this, 6 is the LCM. 2 plus 1 plus 2. 3 by 6, or RP is reciprocal 6 by 3. So 1 by 6 is 3 by 6. So RP will be 6 by 3, which is 2 ohms. So you have solved the network. So this particular part of the circuit is equivalent to 2 ohms. Means instead of connecting these three things, you can just connect one single 2 ohm resistor. Now you can see that R5, this 2 ohm, and R1 are in series. All three are in series. So final equivalent resistance is R1 plus the network, that is RP, plus R5 are all in series, which is 3 plus 2 plus 3, which gives you 8 ohms. So the equivalent resistance in the whole circuit is 8 ohm. So instead of the whole complex circuit, you can just use one single 8 ohm connection. Current is I is equal to V by R, Ohm's law. V equal to IR, I equal to V by R. V is 4, R is 8, we just found out, which is 0.5. 1 by 2, 0.5 amperes. So your final answer is 0.5 amperes. Our final question, which is 2 lamps, one rated 40 watt at 220 volts. So watt is the unit for power. So it's a power question. And other is 60 watt at 220 volts are connected in parallel to the electric supply. A, draw a circuit diagram. B, calculate the current. And C is calculate total energy. So we have power and V, potential difference. We have three formula for power. So out of the three, you have to use one. First is draw the circuit diagram. It's pretty simple. So the two lamps, you can either draw the symbol for lamp, the bulb symbol, or you can draw it as just resistance symbol, since lamps are also resistors. So draw two lamps which are in parallel. It's given in the question, they are parallel. So this is lamp 1, lamp 2. So lamp 1 is 40 watt 220 volt and lamp 2 is 60 watts 220 volts connected to the electric supply, and this electric supply is 220 volts for both of them. Common electric supply as given in the question. So we have drawn the circuit diagram. We add a key or a switch also to it. Part B, calculate the current drawn from the electric supply. So I will separately find out for the lamp 1 and lamp 2, I1 and I2. Since from the main supply, current gets split since they are in parallel into I1 and I2. So let's find out I1, I2 separately, and then you can add to get the total current. So how to find out I1 and I2? For I1, P1 is given, first power, and voltage for the first lamp is given. Similarly, power for the second lamp and the potential difference or voltage for the second lamp is given. Now, which is the formula that you can use which connects power, potential difference and current? What is I1 and what is I2? So as I said, power has three formulas. Which are the three formula? P is equal to VI. Then we have another formula for power, which is I square R. Then you have one more formula, V square by R. Out of the three, which one will use? The first one, P is equal to VI. Just because V and P are given and I is asked. So this formula can give you the answer. So from this, I1 can be P1 V1. Similarly, I2 will be P2 by V2. So just substitute your step 3 substitution and step 4 calculation. So 40 by 220 is 0.18 amperes. Similarly, find out I2. Just calculated I1, calculate I2, P2 by V2, which is 60 by 220, which is 0.27 amperes. So you have separately calculated the currents. You can add them, I1 plus I2, to find out the total current, 0.18 plus 0.27, which is 0.45 amperes. This is your calculation. Now let's get to part C of the question. Calculate the total energy consumed by the lamps together when they operate for 2 hours. So energy you need to find out, E, and time is given, T, and power is already known for both the lamps. So immediately it should click which formula to use when energy E is given. E is asked, time is given as 2 hours, and power is given. For first lamp it is 40 watts and second lamp it's 60 watts. So the formula that involves P, E and T is energy is equal to power into time. Very important formula in power. So here one more thing you need to remember. You'll find out energy for the first lamp separately and energy for the second lamp separately and add them. So E1 is first power into the time for that, and power is given in watts, which you have to convert into kilowatts since time is in hours. So you can either convert power in kilowatts or time in seconds, but since it is a electrical appliance used in homes, we will prefer to find out in kilowatt hours. So power into kilowatts. So you do this for both the lamps separately. So what is the total energy? Just add both of them. You can re-watch the previous steps. The total energy is 0.2 kilowatt hours. Or you can also write as 0.2 units. So when we convert power in kilowatts, you get the answer energy in the units kilowatt hour. When you can keep power in watts and time into seconds, then you get the answer in joules. Now in certain questions they give that suppose rupees 3 is charged for each unit, find the electricity bill for the month of April. So you just multiply with them. Very important question. Now let's get to part 3, practice worksheet. So for practice worksheet, please check the description box. I have added a PDF. You can check it to find out to find practice worksheet.